In this problem, it says that a television show conducted an experiment to study what happens when buttered toast is dropped on the floor. When 46 buttered slices of toast were dropped, 28 of them landed butter side up and 18 landed butter side down. So we're going to use a 0.01 significance level to test the claim that toast will land with the butter side down 50% of the time. So the first part of this question is asking for the null and alternative hypotheses. So we have the null hypothesis that P is equal to 0.5, and that's because it said that we are testing the claim that the butter side lands down 50% of the time. So we're saying that's equal to 0.5, and that's our claim. And then the alternative hypothesis is that P is not equal to 0.5 because we don't have any indication here of greater than or less than, so we have to go with not equal to for the alternative. So now we're ready to put our information into the calculator. So the data that we have from this problem is that the number of successes, which in this case is butter side down, is 18. So 18 times the toast landed butter side down, and the number of trials was 46. So we're going to take this information and we're going to put this into the calculator. And because this is about a proportion, we're going to use one prop z-test. And that is number 5 in your test list. So to get to here, you're going to choose stat and then go over to tests. And you'll find number 5, one prop z-test. So now we're going to put the information into the calculator. The first thing they ask you for is P0. This is the value from the null hypothesis, so that is 0.5. Then we put in our data. So we have 18 successes out of 46 tries. Now we're going to put in the alternative hypothesis. So this says prop, and then we choose not equal to P naught, or less than P naught, or greater than P naught. So what we want to realize here is that prop is your variable P. So we're looking at the alternative hypothesis. P is not equal to 0.5. The P here is the prop, and the 0.5 is P naught. So we're going to choose not equal to P naught for this particular instance. But just keep in mind that the P0 or P naught is not the variable P, so that gets people confused sometimes. And now I'm ready to calculate or draw. And so when I get my test statistic and my p-value, and I can choose either calculate or draw. So my test statistic is going to be a z-value, and that turns out to be negative 1.47. And the p-value is 0.140. They ask you to round it to 3 places. So we put in our test statistic and our p-value. So now I have my test statistic and my p-value. So with a p-value of 0.140 or 0.14, and we're comparing that to alpha, that's our significance level, and that's 0.01. So in this case, the p-value is greater than alpha, and that tells me that I should fail to reject the null hypothesis. Because what we're doing here is we are looking at our critical value alpha. This was a two-tail test. So alpha is split between the two tails. And our p-value is also split between the two tails. And in this case, we have a p-value that is larger than alpha. And what that means is that our test statistic, that was negative 1.47, is falling very close to the center, or at least close enough to the center that we do not want to reject the null hypothesis. So when that test statistic is falling close to the center, we want to not reject the null hypothesis. If the test statistic falls into the rejection region, that's when we reject the null hypothesis. So we're going to fail to reject the null hypothesis. And then we want to make a statement. Now, since the null hypothesis was the claim, I like to mark that down at the beginning of the problem when I'm thinking about that, because now when I come back from the end of the problem and when I'm forming my conclusion, I look at that and I say, well, the null hypothesis was the claim. So I want to make a statement about whether there was sufficient evidence to reject the claim. If the claim had been the alternative hypothesis, then my statement is going to be about support. So in this case, we are going to say there is not sufficient evidence to reject the not sufficient evidence to reject the claim. So there is not sufficient evidence to reject the claim that buttered toast will land with the butter side down 50% of the time. So that's the end of that problem. Or I should say that's the end of the hypothesis test. But now there's a follow-up question about what if we change the alternative hypothesis. Okay, so now it says to write a conclusion that addresses the test, that the toast will land with the butter side down more than 50% of the time. So I'm going to go back to my one prop z-test, and I'm going to put in all that information again. So p0 was 0.5 because we're looking at the null hypothesis that p is equal to 0.5. But now our alternative hypothesis is that p is greater than 0.5. So we're changing this from a two-tail test into a right-tail test. X is still the same, N is still the same. So if you're doing this in your calculator, you can just skip over those that's already entered. And then when you get down to prop, you're going to want to say greater than p0. And so when you get your test statistic, that's going to be the same value. That's going to be z equals negative 1.47. So we've got our null hypothesis here. We've got the alternative. And then we look at our test statistic and our p-value. And our p-value is pretty large. It's 0.9 something. And what we are going to conclude then is there is not sufficient evidence to support the claim, which is now our alternative hypothesis. So notice that they use the word support here. And there is not sufficient evidence to support that claim because we are looking at our distribution here. Our claim is that the proportion is greater than 0.5. So if here is 0.5 in the middle, then when we get our test statistic way back here, p-value is this area. And so our p-value is greater than alpha. And so we are going to fail to reject the null hypothesis again. And so therefore, if we're not rejecting the null hypothesis, then we can't support the claim. So that's how you do that problem.